Assalamualaikum and hi everyone. Today we want to talk about the preparation of activated carbon from sunflower seed hull for supercapacitor application. Before we start, I want to introduce our group member. For the first one is our supervisor, Puan Nurha binti Abdul Hadi. The next one is Muhammad Umar Hazib bin Abu Bakar, Muhammad Haiman Sakawi bin Hairul Sugiman, and also me, Muhammad Amar Hakimi bin Muhammad Zaini. We all from RAS 1205B. This is our table of content for video presentation.
For introduction, background, harsh environment pollution, and fossil fuel usage, highlight the urgent need for renewable energy solution. Supercapacitors are promising device because they offer fast charging, long lifespan, and high power density. Nowadays, activated carbon has been widely used due to its large surface area and functional groups. Recently, sustainable precursors such as peanut shells, orange peel, and sunflower seed hulls has gained attention. For scope and objective, this study focused on preparing activated carbon from sunflower seed hulls using a lab scale method. The effectiveness of the hulls is evaluated using carbon yield and ash content. The objective is to develop low-cost, renewable, and high-performance electrode material. Significance of study: the study tests sunflower seed hulls as a cheap, renewable source for activated carbon, and it gives basic data on carbon yield and ash content for supercapacitor use. The methods: the sunflower were dried to remove moisture, they were carbonized in a furnace, and it was ground, sieved, and soaked with KOH for activation. The material was washed until neutral pH and dried again, and carbon yield and ash content were measured. For overview of the result, activation was successfully made from sunflower hulls, yield was good, and ash content was low.
Moving on to the literature review, we'll be focusing on 4 topics, which is supercapacitor, electrode, activated carbon, and biomass. Supercapacitor is a type of electrical energy storage system that are becoming popular due to its fast charging and discharging capability and its ability to promote renewable energy technology to making and usage. Supercapacitor is seen in being used in high quality camera, radar system, and electrical vehicle. Electrodes are made by using 3 types of material, which are polymer, metal oxide, and activated carbon. As to save cost and to create an environmental friendly product, activated carbon are primarily used. The reason that activated carbon is widely used in making electrode for supercapacitor is due to its network of porous surface that provide a large surface area for charges to bind to. This will allow the electrode to hold many charges, which provides its characteristic fast charge and discharge capability. There are 2 ways activated carbon can be produced. The first is physical activation method, and second, chemical activation method. For this research, we will be focusing on chemical activation method. Chemical activation method: raw material is submerged in with chemical activating agent such as phosphoric acid or potassium hydroxide to decompose the material and form the porous structure. In this method, it will result in higher efficiency of production when compared to the physical method, though it requires a precise ratio of activating agent and raw material to prevent over decomposition to occur. Biomass are used intensively in making activated carbon. Biomass are inexpensive, abundant, and rich in carbon content, suited for activated carbon production. Biomass can also help promote environmental technology as it helps reduce agriculture and food waste. Examples of biomass that have been used in making electrode are corn cob, date palm, groundnut shell, and betel nut. In this research, we will be focusing on sunflower seed shell as a likely candidate in making activated carbon. Sunflower seed shell are uneatable and often end up as food waste. In China, sunflower seeds are used for oilseed crops, which generate huge amount of shell waste. These shell have been noted to contain cellulose, hemicellulose, and lignin, which promote rich pore channels and density during the activation process of activated carbon.
Methodology. The feedstock is sunflower seed house. Equipment is laboratory oven, muffled furnace, vessel mortar, and sieve. Chemicals is diluted KOH, distilled water, and pH paper. Glassware is beaker, conical flask, and aluminium foil. Filter paper. Other is vacuum pumps. For methods, the drying process. First, we are gonna dry the sunflower seed husk in oven for about 2 hours to remove the moisture, and then we are going to put it into muffled furnace for about 350 degrees Celsius for 45 minutes. This is important to make it as a porous structure and high carbon content. The significance is pyrolysis is efficient, sustainable method to convert agricultural waste into activated carbon precursor. For activation process, first we grind the biochar and then we sieve it using 150 micrometer sieve to form a uniform particle size. And then for chemical activation, we soak the biochar in diluted KOH 1/3 ratio for 1 day to develop the pore and high surface area. The effectiveness of KOH is produce microporous structure and it's ideal for absorption, gas storage, and supercapacitors. And then we wash the biochar using distilled water until neutral pH 7. And we also use vacuum pump to help the suction faster, and pH indicator ensure contamination free final activated carbon. For the final process, clean material was oven dried for 4 hours, and then the final activated carbon obtained in weight is evaluated by carbon yield and ash content as indicator of quality and purity.
This is the result that we got from the analysis of the experiment, and we got the percentage yield, also the ash content by using this all equation. For the percentage yield, we got 55.26% and also the ash content of 0.89. For the discussion, activated carbon was successfully produced for sunflower seed hull using carbonization and KOH activation. Weight reduction at each stage confirm effective drying, carbonization, and activation process. Moisture removal reduced weight from 41.4 gram to 38 gram, ensure that good carbonization quality. Carbonization reduced the mass of 21 gram, indicated formation of carbon-rich biocarb. KOH carb activation and washing to pH 7 improve porosity and ensure the sample purity. Final weight of reduction to 18.7 gram resulted from pores development and impurity removal. The carbon yield 55.26%, showing the good conversion efficiency, and the ash content 0.89, indicating the suitable for capacitor electrode use. Conclude this video presentation. This research conduct on the preparation of activated carbon from sunflower seed hull for supercapacitor application has yield valuable insight and encouraged result. Through the carbonization and activation process, sunflower seed hull sample will transform into activated carbon with suitable properties for use in supercapacitor. Sunflower seed hull and agriculture waste and can be used as a low cost and renewable source for activated carbons in supercapacitor. For future research, the preparation of activated carbon from sunflower seed hull should be assembled as an electrode in a supercapacitor device to evaluate its electrochemical performance, including energy density and specific capacitance. Other than that, morphological analysis using scanning electron microscopy (SEM) is also recommended to observe the pore structure and surface morphology. This study would establish the relationship between material structure and electrochemical performance to sustain its potential use as a suitable supercapacitor electrode material. These are the reference that we use. Also, these are the reference that we use in the video presentation. That's all from us. I hope you guys enjoy with our video presentation. Thank you. Turning sunflower seed hull into energy storage solution.